Hi, I am Gary Hatch, author of this publication entitled Fate of Pathologically Bound Oxygen Resulting from Inhalation of Labeled Ozone in Rats. I am a researcher for the United States Environmental Protection Agency, located in North Carolina, USA. Ozone air pollution is formed from oxygen when emissions from cars and industrial processes are acted upon by sunlight. This ozone at ground level can cause negative public health effects. Epidemiology studies show an association between high ozone days and asthma attacks, as well as increased deaths resulting from cardiopulmonary events. It was recently estimated that ozone pollution is responsible for about 500,000 premature deaths per year worldwide. Animal inhalation studies support the human epidemiology. For example, mice with a genetic defect in blood lipid packaging have increased atherosclerotic plaques when exposed to ozone, suggesting that ozone can have effects outside the lung. Ozone forms chemical addition products, or adducts, with a variety of biomolecules, making it a good model for the study of oxidative stress. It is believed that oxygen adducts caused by ozone would disrupt function and need to be repaired. However, little has been known about this process. Macrophages that clean the surface of the lung, as well as surfactant lipids that coat the airway surfaces, receive an especially high dose of ozone. When ozone is inhaled, it is akin to spray painting the macrophages in the alveolar surface with pathologically bound oxygen. A previous search for non-invasive markers of oxidative stress following ozone exposure in rats showed that traditional measurements were not effective. Our study investigates the fate of this bound oxygen by exposing rats to oxygen-18 labeled ozone, then measuring the levels of oxygen-18 in the blood and urine of the rats following exposure. Oxygen-18 is a non-radioactive, heavy form of oxygen that can be used as a tracer. We generated labeled ozone from labeled oxygen. The use of oxygen-18 is necessary because radioactive forms of oxygen have extremely short half-lives. Few studies have employed oxygen-18 to measure pathologically bound oxygen because the techniques require isotope ratio mass spectrometry, and it is difficult. Our study is unique because it is the first to show that molecules oxidized by ozone leave the lung and enter the circulation. Also, that these molecules might be sequestered for a time before being excreted, and that they are mostly excreted and not recycled. We examined some of the properties of the excreted adduct material, such as molecular weight and heat stability, and hope that our results will aid the future search for clinical markers of oxidative stress. I want to thank the co-authors of the paper, Ralph Slade and John McKee, as well as several other people listed here who gave excellent assistance. Thank you for watching this video. I hope you enjoy the paper.